The cell membrane is a lot like a coffee filter because it lets some things pass through, but not everything. So your cell membrane keeps big things like your little organelles on the inside, but it lets smaller things like water pass through. So this coffee filter, again, acts much like a cell membrane. It's got coffee grounds, and if we pour some water through the filter, we can definitely see that water is pouring through, but the coffee grounds stay on top. Same concept, but with tea. The tea bag is like the cell membrane. It keeps the little leaves on the inside, but it allows the flavors and some of the smaller compounds to move in and out of the bag. At this point, we can kind of see the turmeric floating into the water. It's passing from the inside of the bag to the outside of the bag. So something small can float through, but the big leaves are not escaping. Your cells want to maintain an equilibrium. So if you put your cell, an animal cell, in salt water, like super salty salt water, there's more water inside your cell than its surrounding environment. Water is going to want to leave your cell to maintain a balance, thereby shrinking your cell. This super sugary gummy bear is I'm gonna put it in this little glass container, and I'm gonna put some water in it. And again, everything kind of wants to maintain a balance. So the water is going to go into the gummy bear, engorging it, enlarging it. Like if your cell was put into an environment that was more watery, like had maybe 90% water and your cell was 80% water, they want to maintain a balance. So water is going to go from the outside environment into the cell, engorging or enlarging the cell. After letting this gummy bear soak overnight in water, we can see that it is much longer than the original gummy bear. So this one definitely gained weight. So for your lab today, you're going to get a slice of potato. This is just, like a normal red potato. But all living things are made of cells, so this potato slice is full of potato cells. And you're going to see what happens when you put it in different solutions, if water is going to go into the cells or out of the cells. So we need to measure the mass of this potato. Then you're going to decide, oh hey, I'm going to put this potato in water, and this is pure water, so there's probably more water in here than in the potato cells, so the water is probably going to go into the cells of the potato, making this heavier than when it started. And you're going to measure the mass every 5 minutes or so. Alternatively, you could be like, okay, this is a potato cell, or this slice of potato is full of potato cells, and it's watery. It's not completely water because there's salts and other little ions in here. If I put this potato slice in a cup full of super sugary thick honey, there's probably more water in the potato cells than in this bit of honey. So the water is going to move out of the potato cells into the honey, shrinking the mass of the potato. So this one should probably lose weight, and this one should theoretically gain weight.